Yeah.
Yes.
7 o'clock. Let's look at two different points. A. And B. Shortest distance again. First view is the points lie on the equator, right? And what about these longitudes? Do they add up to 180 or something? No, it doesn't.
They won't add up to 180.
So these points are on
Different longitudes.
on the equator, but yes, different longitudes. Correct. So let's draw both the views and see. So first, as you said, we'll draw the front view. So it's north, south, east, west. Equator. So you're looking from the anti-prime meridian side.
Yeah. Yes.
Anti-prime meridian side. Two different longitudes. One is 165.35 east. Where should I mark that?
Eastern will be towards my left.
Towards the west. Sure.
Yeah, towards the west, yeah.
165 degrees 35 minutes east, and this
will towards east.
towards the east. So you still can have a westerly longitude on the towards the east. It is possible. That's because you're looking from the anti-prime meridian side, right? Now let's mark the points here. Point A is on 165.35 east. Therefore, this is point A, and point B is on 165.25 west. Therefore, this is point B. So you're traveling from A to B or B to A, doesn't matter. So let's imagine you're traveling from A to B. Along what are we traveling? We are traveling along a great circle. Therefore, it is a great circle track from A to B. What track are you flying? So if I mark the great circle track as GC, this is the great circle track from what? From A to B. This understanding is actually quite helpful for your convergence, other type of topics. So you can see the word here, from and to. So I'm more interested in this from word, where I probably keep my pen or my finger at the from side. So from A, I'm moving towards B. So I can write this as great circle track from A to B. So where I start, the from is always written first. This is only my way of writing it. Sometimes textbooks can give you GCBA and they will say it is great circle track to B from A. It is, as long as your understanding is correct, it's going to be the same. Right? So it's great circle track from A to B. From A to B is how much? What's the track?
A to B is easterly track. It is flying easterly track.
Very good. It's exactly flying an easterly track. How will you measure the track? We have seen that before. True direction system.
Yeah. From here, we'll draw the local meridian.
That's
from
right.
local meridian, clockwise I'll measure my track.
Very good. From
That
the
will be
local
90
meridian
degrees.
clockwise. So what do you think it is? It is you're traveling along the equator.
090.
So equator lies in exactly easterly and westerly direction. Therefore here it is 90 degrees. The easterly track is always a 90 degrees track, and since it's measured from true north, it is 90 degrees true. What if I was traveling the other way around? So if I had traveled from B towards A, the distance is not going to change. So as far as this question is concerned, that is not going to affect the answer. This is just some add-on information. When you travel from B to A, the statement will be GC, great circle track. Now it is from B to A. So again, look at the from and keep your pen here. It is from B. So your orientation is from your view is from here now. It's from B towards A, right? So that is great circle track from B to A. What track is that? That's going to be along the equator in the opposite direction. Therefore, it's a westerly track. So you can see that in the initial case, you are just running with the earth. this case you're running opposite to the Earth. Earth is still rotating in that direction, right? So what track is that? 90 degrees true?
270 degree
right.
true.
270 degrees true. So here you can see the westerly track is 270, but a westerly meridian is going to be 90 degrees west, as we saw yesterday. That won't be 270, right? So these are the tracks which you're looking at. So when you're tracking along the equator, you either track easterly 90 degree track, or you'll be tracking westerly 270 degrees track. And that goes with all the parallels of latitude also, because parallels of latitude also line the same plane parallel to the equator. So if I'm tracking along 30 degrees north towards east, it's the easterly track of 90. Over this side, it's always westerly track of 270, right? Yes. So how will you find the distance now? Basically, we have to find out the angular change. Center of the Earth is straight here. Say for example, I'm traveling from A to B. So here, in this case, great circle track from B to A. I'm measuring the track from B to A. How will I measure the track from B to A? Local meridian passing through B.
I'll draw a local meridian. From that point, I'll draw clockwise till the aircraft, like till the path.
This is more convenient, but that's wrong. It's always in the clockwise direction. And therefore, this is what is 270. That is why it is 270. Right? Now to find the distance, you have to find the angular change, but angular change is always at the center. Therefore, we're looking at the angle formed here. That's measured from A to B in this case. Therefore, what is that angle going to be? It's basically the chilong, or the change in longitude between A and B. Yes, so what is the chilong?
That will be like 180 degree minus 165.35. Or like we can see that from A to till prime meridian, the change in longitude plus the change in longitude from prime meridian to point B.
That's correct. So basically you can subtract 180 degree, subtract 165.35 from 180 and 165.25 from 180 and add those two. Right?
Yeah.
Or what you can do is you can add these two together and subtract it from 360.
360 degrees.
The total, right? Both of that is, but it's simpler. So before we do that, let's look at the top view. So will top view help?
Top view. Yes, it will also help.
It will, because the points are actually on a particular hemisphere,
on the equator,
and they are so that's the whole thing. If it's the same hemisphere, top view is going to help you, right? So let's draw the. It's always a good practice to kind of draw the meridian and prime meridian, anti-prime meridian for top view. Prime meridian, anti-prime meridian. And it's always a good practice to draw prime meridian here and anti-prime meridian there. It's just like you have a globe, you're going all the way up and looking down. So prime meridian is this side, down, and anti-prime meridian there. What happens if you put anti-prime meridian here is your sense will has to be reversed. And if you don't reverse your sense, then it will go wrong. So always make sure you draw prime meridian down, anti-prime meridian up. Right? Now let's look at first meridian 165.35 east. Therefore this is going to be your eastern hemisphere. Therefore the 165.35 east is here, and this is going to be 165.25 west. Now don't think that why this is east or to your right, west is to your left, but here west is to your right, east is to your left. These are two different views. This we are looking from the anti-prime meridian side, this we are looking from the top side. That's the difference. Right? Yes, now we are looking at this angular change here.
Yes.
This we are trying to measure. So you can see that what is this 165.35? 165.35 is this angle measured from the prime meridian towards the east, right? And this angle is 165.25 measured from prime meridian, right? So the total is 360. You can add these two, subtract from 360. That is going to be much more easier than individually subtracting these from 180 and then adding, because ultimately it's the same. Right? So the easiest way to find out the chilong will be 360 degrees minus 165 degree 35 minutes plus 165 degree 25 minutes. So how much is that?
It's 29 degrees.
Straight? That 29 degrees straight? Is that chilong?
Yeah.
Alright.
Yes.
So now we can find the corresponding distance, the distance corresponding to that. That's right here, which corresponds to the distance here.
Yeah.
So I'll draw the assume it's from A to B. Therefore, how do you find the distance? 29 degrees is
multiplied
by 60.
60.
1740 minutes.
Yeah.
Right? And take a pause here. Can we convert? Can we apply the conversion straight?
Yes.
Right?
So since we are on the equator, on the equator is on the great circle.
That's right. So 1 minute is equal to 1 nautical mile. So they cannot give you anything other than equator here, because on this particular plane, anything other than the equator is not a great circle. And this particular point of the syllabus, you're not introduced to departure, and therefore they would probably won't give you a question that here, right? So it's 1 minute is 1 nautical mile. Therefore, it's 1740 nautical miles.
Nautical miles. Okay.
Right? It's two different views. This is actually more convenient and more simpler, because you can actually get a proper view of the entire longitude system than this. This, though, you have to have a 3D picture to kind of understand this. Right? But as long as you can understand, it's also fine. But so usually I find it's more easier to explain to students. They pick up very quickly. Right? So you can draw these views.